Students, and welcome to the continuing lesson on estimating population proportion. In the last video, we talked about some definitions and key terms regarding margin of error, and now we are actually going to do an example problem. So this problem reads, a Pew Research Center poll of 1,501 randomly selected U.S. adults showed that 70% of the respondents believe in global warming. The sample results are n equals 1501 and p hat is 0.7. Okay? And really, you didn't really need this second part here. I'm sure you could have deduced this just from the problem. Okay? So 1, find the margin of error that corresponds to a 95% confidence level. Okay? Well, let's see what that means. So remember the formula for margin of error, that E is equal to Z alpha over 2 times the square root of P hat Q hat all divided by N. Okay? So we already know that P hat is 0.7, so that means Q hat, which 1 minus 0.7, is 0.3. And N, which was given to us in the problem, is 1501. Okay? Now let's see what this Z-score is. Well, if the confidence level is 95%, and in this case we're talking about a two-tailed test, okay, because ultimately we are going to create this confidence interval. So there is a lower bound for the things that are too extreme. There's an upper bound, and we're going to try to narrow in on the correct population proportion as much as we possibly can. Okay, so this is going to be a two-tailed test, and this area here, that's the confidence level. We're given that it's supposed to be 95%. Okay, so that means alpha is 1 minus 0.95, so alpha is 0.05. So this is Z alpha over 2, so this is the Z-score that corresponds to 0.025. So this Z-score right here. Okay? And so there's a couple ways for you to look at this. You could either use your chart, or you could just as well use your TI-8384 graphing calculator. Okay, so we clear all of that out. So we go to second distribution inverse norm 0.025, and this gives us about negative 1.96. So it's negative 1.96 and 1.96 on each side. There's a negative number, there's a positive number. It doesn't really matter which one you use. It's going to produce the exact same result. So I'm just going to use the positive one for now. Okay. So let's look at the margin of error. So this is equal to 1.96 times the square root of 0.7 times 0.3, all divided by 1501. Okay. And if you do this correctly on your calculator, you should get 0.0232. And remember, we are rounding to 3 significant digits. Okay, so there we have it. This is the margin of error. Now let's see what else we're asked to find or to solve here. Find the 95% confidence interval estimate of the population proportion. Okay. Well, the confidence interval, if you recall, is P is between P hat plus the margin of error and P hat minus the margin of error. Whoops. And so now we really just need to make some substitutions. So P hat is 0.7. Remember, E is 0.0232. This is 0.7. Excuse my sloppiness here. Plus 0.0232. So you complete the arithmetic, and we get 0.7232 and 0.6768. Okay, so this here is the answer to number 2. It's the confidence interval. Okay, and so at this point we're just throwing a lot of numbers, a lot of formulas around. Okay, it's important, and we'll deal with this in just a moment, to try and interpret what this all means. So number 3, based on the results, can we safely conclude that the majority of adults believe in global warming? And I would say yes. Okay, we can say yes because, you know, this is the correct proportion is in this range. At least we are 95% confident. Okay. Now 4. Here comes this tricky part. Assuming you are writing a newspaper, you are a newspaper reporter, write a brief statement that accurately describes the result and includes all of the relative information. Okay. And so let's try to interpret what this really means. And we're saying that we are 95% confident. Remember that. This is some basic information here. Okay? So there's a very, very common misconception in how to interpret this information. A lot of people seem to think that this is saying there's a 95% probability. Okay? So let me show you the wrong interpretation. That there is a 95% probability that the correct answer or the correct proportion is between 0.6768 and 0.7232. Okay, this is definitely an incorrect interpretation. Unfortunately, it's a very common error. Okay. So let me kind of explain why this is incorrect. Excuse the goofy camera work here. Okay. So what this is saying is that this is the interpretation. It's saying that between these two numbers, 0.6768, this is some numbers on a number line, and 0.7232, that there are a bunch of different correct answers. So we're assuming that there's like 100, correct answers, and 95% of them appear in here, and some of them are outside. That's what this statement is saying. There's about 100 different correct answers, and there's a lot of them in this interval, and then a few of them outside. And that is completely wrong. Okay? Although it seems to make sense when we say it like that, because the truth is there is only one correct answer. Okay, so let me give you the right way to say this. That this is the answer to number 4. Okay, if there were many samples of 1,501 people, many, and so there, as the more samples, the better. Okay, 95% of those confidence intervals would contain the correct answer. So this is the correct interpretation. So it's like saying there is one correct answer. Okay. And there's lots of confidence intervals. Ours is one of them, 0.6768, 0.7232. And there's some other interval like this, and maybe some other interval, and some other intervals here, and maybe some intervals that misses it altogether. So there's one correct answer that's this middle line right here. Okay. And there's a bunch of different intervals that are calculated, and 95% of the intervals contain this correct answer. Whereas the wrong answer is saying that we only have one interval, and there's 100 different correct answers, and 95 of them are in here. Okay, so we got to be really careful how we state this. This is very, semantically intensive or tricky. Okay, but it's a very significant and important difference. Okay, so we're done with that part now. Next, you repeat the poll but you want a 98% confidence level, what sample size is needed? Okay, so one theoretical question that we deal with is like, is it possible for us to just make this a 99% confidence interval level, or why can't we just make this a 100% confidence interval? Well, that's perfectly fine, but the higher the confidence level, the wider the interval is going to get. Let me say that one more time. So the higher confidence level means a wider interval. So I can say that I am 100% confident, okay, that the answer is somewhere between 100% and 0%. Right? This is absolutely correct, but it isn't very useful. Okay? So if we want to have a high level of confidence, but we also want this interval to be very small so that it's useful. Okay? So what if we wanted a 98% confidence level? Okay. So we want the same margin of error. We still want the margin of error to be the same, to be this. Okay. The formula pretty much stays the same. P hat hasn't changed. Q hat hasn't changed. N is what we're looking for. We don't know how big this is. And now we need, this is Z alpha over 2, and this time it's for 98%. Okay. So make the bell curve, two-tail. This stuff here in the middle is 0.98. This on the fringes, okay, the combination of these two is alpha. So alpha is 1 minus 0.98, which is 0.02. And so we're looking at Z alpha over 2. Oops, excuse me. So we want to look for, we know that alpha over 2 then is equal to 0.01. So then we want to do inverse norm on this amount. Okay? So we'll do inverse norm 0.01, and we get 2.23. And again, there's going to be a negative value, there's going to be a positive value, but we're going to use the positive. That's going to be more helpful to us. So 0.0232 equals 2.32 square root 0.7, 0.3 over n. Okay. Now we have to do some algebra. Divide both sides by 2.23. Then square both sides. And then we can multiply both sides by n. So n times 0.0232 over 2.32 squared equals 0.7 times 0.3. Okay? And then divide both sides by this quantity here. So n equals 0.7, 0.3 divided by 0.223 over 2.32 quantity squared. Okay, and so this is kind of a big mess here, but again, this right side, it's complicated looking, but it's just a number. Okay? So I'll even do this algebraically, or using mental math. 0.7 times 0.3 is 0.021. I'm sorry, there's just 0.21. Okay, all of this divided by 0.23, I think it's going to give us 0.1. .01 rather, squared. So n is going to be 0.21 over 0.1 times 0.01 times 0.01 is 0.0001, and 21 divided by that is going to give us 210123. So if you want to increase the confidence level from 95% to 98%, then what we need here is a sample size of 210,000 people. Okay, and so that's a huge number. You can see why sample size is so important. And you can also see why we like some of these numbers to be a little bit lower at 95%, because this is the difference between interviewing 1,500 people and interviewing 200,000 people. And then finally, 7, you repeat the poll, but you want 99% confidence level, and p-hat is unknown. So what if you didn't even know what p-hat is? So if p-hat is unknown, then let's just repeat the same process. Okay, so we know we want the error to be 0.23. Z alpha over 2, this is just going to be, so we want this section here to be 0.99. Okay, so it means alpha is 1 minus 0.99, so 0.01, and alpha over 2 is just 0.005. Okay, so we repeat this process. Inverse norm of 0.005, and that gives me 2.58. So we're looking for Z of 0.005, and that's 2.58 times the square root of, now p-hat is unknown. Okay, so we're going to do some estimate. So if we don't know whether or not something is true, it's either true or it's not, we assume that it's just 50-50. So assume 0.5. Okay, so p-hat is 0.5, q-hat is 0.5 divided by n. And now we need to solve that equation. So we'll go through the same process again. 0.0232 over 2.58 equals 0.25 over n. So 0.5 times 0.5 is just 0.25. Square both sides. Multiply both sides by n. And then divide both sides by this number. So n is equal to 0.25 divided by 0.0232 over 2.58 quantities squared. Okay? You just plug that into a calculator, and let's see what we get. Here, we'll need a sample size of about 3,092 for our final answer. So if we didn't know what p-hat was equal to, we can make this assumption. If we do know what it's equal to, then we need to use that value. All right. Well, there you have it. The most important part of this video was the part where we interpreted the confidence interval. Okay? And there's a wrong way to do it, and there's a right way to do it, and they're very similar in the wording, and people really confuse them. Okay? But it's important to go back and look at that part and make sure you can internalize that. Once again, as always, ask for help if you need it. Thank you for watching, and have a wonderful day.